one, as we're going, we want you to have all of this information studied. That's why we'll be putting up the video. For your ones that are going to take a conversion, we'll make sure you have the conversion factors up on the board. Remember, when I'm doing a conversion, I'm going 4 grams and I'm going 2 milligrams. So I'm going to use the right side of my proportion as my conversion factor. I told you at the start of the class, 1 gram is 1,000 milligrams. So this is actually the time I'm going to get that as a times. Get fractions, I have to put it over 1. They're both on top. That means I'm just multiplying. The grams are going away, so this is 4,000 milligrams. Same thing on the ounces. 6,400 ounces. And I just put my conversion. I'm going to pounds, that goes on top. I'm going from ounces, that goes on the bottom. Again, I'll put it over 1, my conversion factor. There are 16 ounces in 1 pound. We're on opposite sides, that means I'm actually dividing. 16 will go into 64. I know that, so I'm going to do a reduction first. That's going to go 14 times. So that's going to be 1,400. So now I'm just multiplying. 1,400 times 1 gives me 1,400 pounds. If you don't like to do conversions, you can multiply it. Then it's going to be 6,400 divided by 16, and you can do the long math on that. I've only got 20 minutes, so you can do the math later to see that it's right. When I'm doing a, yes?
Look at 400. Yeah.
Oh, you're right. I don't know why I put that one there. It's 4. It is 400 pounds. Thank you. Question if that's on the, got it. Quiet. Thank you for that correction. It is 400 pounds. On this one, to do mixed numbers, I can focus in on the fractions first. Key in adding fractions, I must have a common denominator. Meaning I'm multiplying both those by 5, both those by 7. That's going to give me 30 35ths plus 7 35ths. If I add that, that gets me 37 35ths. I need to change this to an improper fraction. So that's going to, mixed number. So that's going to be 1 and 2 35ths. But then I also have a whole number of 3. 1 plus 3 gives me 4 and 2 35ths. If you change it to an improper fraction, you'll do the same thing. And then I'm doing 16 times 7, which gets a lot messier. Same thing here. I focus on the fraction. 3 and 4 are going to meet at 12. So I'm multiplying those by 4, those times 3. That's going to give me 8 12 plus 3 12. Once my denominator is the same, I just add my numerators. It gives me 11 12. Then I take the whole numbers. 1 plus 4 gives me 5. And my answer is 5 and 11 12. LCM. That's where your 4 key numbers come in. 2, 3, 5, and 7. I have 6 and 10. What goes into both? 2. Gives me a 3 and a 5. Those are 2-line numbers, meaning I'm just multiplying all of them. 2 times 5 is 10, times 3 means the LCM is 30. My second set, 7 and 12. What goes into both of them?
1.
1. Nice, Actor. Welcome to flying. The master. That means I'm just multiplying them. 7 times 12 means my LCM is 84. Determine each whole for the percent and part given. So this is the whole piece that we did for quite a while, right before break. That's our is and our of. Our percent goes over 100, so that's going to be 32 over 100 equals, it says of what? So I don't know that, meaning the is 68. Can I go straight from 32 to 68? No. Can I simplify 32 and 100?
Yes.
Yes. So your better bet is step this back to make the numbers easier for yourself. I divide those by 2, gives me 16 and 50. Does that go easily to 68?
Yes.
No?
Oh.
Can I divide this again?
Yes.
Yep.
8.
It gives me 8 and 25. Will 8 go easily to 68?
No.
Not really, but I can't go any further, so now I'm at the point where I just have to do it, even though it's not easy. So 68 divided by 8, it won't go into 6, it goes into 68 8 times. Minus 64 gives me a 4. Add my decimal, bring it up into my answer. It goes into 45 times. Now I'm done. So that means from the 8, I multiplied by 8 and 5/10. So I'm going to take 25, multiply by 8 and 5/10. 25 times 8 and 5/10. I have one decimal. Gives me 25, 10, 12, 0. I'm moving to the tens place. 40, 10, 16, 20. I add those up. I get 5, 2, 1, 2. I have one decimal place. So the number is 212 and 5/10. You can go back and watch it slower, but I can't spend the entire time going over the same problem twice. Our next one is 80%. So I'm doing the same setup. Again, here's your setup for these types of problems. My percent goes over 100 equals my of what? I don't know. So my x goes down here. So I have a 16. Will 80 go to easily to 16? No, but can I reduce 80 and 100? Yes. I divide those both by 10. That gives me 8 and 10. Will 8 go to 16? Yes, times 2. So 10 times 2 gives me 20. So the number is 20. Okay. Determine which is the better buy. The better buy. I have to have the same comparison. So this is where you're going to go to a denominator of 1. So they actually have given me 2 problems inside of 1 that I have to figure out. So the first one I need to do is $12.99 for 42 ounces. In order to make my comparison, I need to go to 1 ounce. So if I find out how much per ounce it is, then I can compare. How do I go 42 down to 1?
Divided by 42.
Divided by 42. That's what I'm doing for the $12.99.
Divided by 42.
Divided by 42. This one is not very pretty, but it's not all that bad. Dividing by 42. 42 going to 1. No, it's 12. No, I'm bringing my decimal up. We're going to 129. Yes, 3 times. So that's going to give me a 6. 12 gives me 3. Bring down the 9. Well, 42 going to 39. No. So bring down another 0 because I need to go to the next place ordered round. We'll go to 42 going to 390. Yeah, 4 to 5. Yeah. So that means I'm going to round this one up to 31 cents. So that's going to be 31 cents per ounce. Okay. Our last one here, we have $5 and 3 pounds. Oh, that's what I've got to go. 99 and 10 ounces. And I know it's going to equal something. And I want 1 ounce. How do I go from 10 to 1?
Divide by
10. So here I divide by 10. That means I'm just moving my decimal place over once. So 0.299 is around to 30 cents, which is better, 30 cents or 31 cents? 30. So the second one is my better buy, so $2.99 is better. It saves me 1 cent per ounce. Sorry, thank you for catching me on that. On this one, now again, I'm going down to 1 pound. How do I go from 3 to 1? Divide by 3. So my 5, I'm going to divide by 3. The $5 divided by 3, that's going to go 1. Gives me a 2. My decimal comes up. I bring the 0 down, goes into 26 times. Times 18 gives me a 2. So we're now seeing a repeating pattern. That's going to go up forever. We can basically round that to $1.67. On the second one, it's $1.50 a pound. They actually gave it to me in 1 pound. So that makes me comparison. Which one's better? $1.50 or $1.67? $1.50. So 150 is better.
I'm so right. I can't see it. I knew it.
Okay, number 6 should be the question on the test. determine at least two equivalent ratios. They didn't give me anything else. That means I get to pick whatever I want. So I'm going to make it easy. I'm going to multiply them both by 2. That gives me 4 eggs and 10 cups of milk. And then I'm going to multiply them both times 10. That's going to give me 20 eggs and 50 cups of milk. I can pick any numbers I want to. The key is I need to multiply my numerator and denominator by the same number. That gives me an equivalent fraction. The second one, I would do the same thing. I'm going to multiply them both by 2. That gives me 40 red and 24 blue. And then I'm going to multiply them both by 10. That's going to give me 200 red and 120 blue. Technically, on the second one, I think they probably want you to reduce for the second one, but you don't have to. You could if you wanted to, but it's me. I multiply by 2 and 10. That gives you a equivalent fraction. Number 7, calculate the volume of the solid formed by rectangular prism. Remember, your volume equals length times height times width. So all I'm doing is multiplying. The key is I need to know my length, my height, and my width for each of the figures. So as I look at this, I see 3 figures. But 1 and 3 are the exact same, aren't they? It's 6 by 2 by 1. So I can technically call those both number 1s. So when I do that, now I'm going to set it up. So I need a length. So a length of 2, a width of 1, and this length is going to be the same as on the far side. So that's going to say 6. So there's my height. So now I just put those numbers into my formula, length, width, height. So I say it's going to be 2 centimeters times the width of 1 centimeter times the height of 2 centimeters. 2 times, my length is 6, sorry. 6 centimeters times 1 gives me 6, times 2 gives me 12. Centimeters times centimeters times centimeters gives me centimeters cubed. Number 2, if I look at this, I have a length of 6, a width of 2, and a height of 1. Oh, actually, that's actually the same as the other 2, isn't it? 1, 2, and 6. So I can take this one number, I multiply it by 3, because all 3 of them have that same volume, gives me 36 cubic centimeters. Make sure you use the correct unit. Yeah. Okay, we have a class of 25 students playing musical instruments. What percent playing the musical instrument? Therefore, that percent does not. I would need to give you 17. So now we're just using the 8 over 25. I know that percent means out of 100.
Guys.
So I'm multiplying it by 4.
Put it away.
Gives me.
You don't need to highlight it right now. It should not be out.
So 32% of students play an instrument. Remember, in the word problem, we answer in a full sentence, correct?
Yes.
Okay, go to the back page. Number 1, evaluate. That means give me the answer. Okay? So we're evaluating each of them. These are our GEMA questions. So I'm going to rewrite this because the most important part in your GEMA questions is making sure you're following the operations. 56 divided by 8 plus 3 times 6. I don't have any groupings. I don't have any exponents. Meaning I'm going to multiply left to right. So 56 divided by 8 gives me 7 plus 3 times 6. Notice I rewrite everything I have not done yet. This is the thing that is going to get you guys on this test. Now I'm going to multiply 3 times 6. I have 7 plus 18. Gives me an answer of 25.
I got it right.
Okay? Our second one, we're going to do GEMA. So I don't have any groupings, don't have any exponents. Multiplication division, I've got a multiplication to start. That's going to be 72 minus 29 plus 30 divided by 15 minus 15. I still have some division, So 72 minus 29 plus 2 minus 15. Done with those, so I'm going to do addition subtraction. 72 minus 29. It's going to give me 43 plus 2 minus 15 gives me 45 minus 15. So the answer on this one is 30.
That includes humming and singing to yourself.
There's an awful lot of doing for our recording. Okay, distributed property. This is literally the first lesson we did this, guys. We did it so many times. And there's still way too many to look at it with blank eyes. Distributed just means I'm moving the outside number to both of the inside terms. And then I need to combine my terms to rewrite each expression. So your first step, we have to do distributive. That gives me 54m plus 9 times 3 is 27. My sign is a plus between them. 6 times 1 is 6. Don't change the sign. It's subtraction. 6 times 4m gives me 24m. Now I'm ready to combine my terms. So I want to find the ones that are the same. So I'm going to take 54m minus 24m. Because we usually do our variable pieces first. Gives me 30m. Then I have constants of 27 and 6. I'm adding those. Gives me plus 33. That is your answer. I can't go any simpler than that. If I have a variable that is different than a constant, those are not like terms, so I can't combine them. This one gets a little more complex because I've got a distributive on top. So I need to go ahead and distribute that number first. So 3 times 4x is going to give me 12x plus 2 times 4 gives me 24y divided by 6 plus 2y minus x. So now I can divide this now that both these terms have a separate number. So 12 divided by 6 is going to make that 2. 24 divided by 6 is going to make that 4. So that gives me 2x plus 4y plus 2y minus x. Combine my x terms first. 2x minus x gives me x. 4y plus 2y gives me 6y. Number 11, rewrite each expression as the product of two factors, so the coefficient of the variable is 1. In other words, use distributive property in reverse. But I want my coefficient to become 1, so I need to look at the number with my variable. That's the number I'm dividing both of the pieces by. So I'm taking the 3 out and making a parentheses. If I divide 3x by 3, I get just x minus 5 divided by 3. And this is one of those few times we'll let you guys use an improper fraction. It's okay to leave it like that. If you want to change that to 1 2/3, we could not count it wrong. But that's literally all you have to do on this. Where it gets a little trickier is when my coefficient is a fraction. Because now I'm dividing both of the terms by 3/4. So my constant, I now need to take 9 and divide it by 3/4. How do I divide a whole number by a fraction? Good, put it over 1, and then keep, change, flip. Keep, change, the multiplication, flip, I'm multiplying by the reciprocal. So I would just go bang, that's a 1 and a 3, I can divide both by 3 gives me 12. If you don't like that, you can do 9 times 4 is 36, 1 times 3 is 3, 36 divided by 3 will still give you 12. So my answer is x plus 12. Those are your answers on those. Again, whole key, find your coefficient. That's the number you're dividing both terms by. Right, and algebraic expressions represent each verbal expression. Here's where you have to be very careful in how you are reading it. Pay very close attention to your flipping phrases. The things like added to, subtracted from. 1/3, the sum of a number and 2 1/100. So the sum of a number is telling me I have to do this first, and then I'm taking 1/3 of it. So I would write that as 1/3, the sum of a number, they didn't tell me, and 2 100. Subtracted from, that's one of your flipping phrases. 2 times a number. So because it's a flipping phrase, this is coming first. 2 times a number and subtracting the 16 2/10. Yes, your order matters. Don't have it in the correct order. Especially and subtraction or division, you get all wrong. Miguel has 3 times as many books as Jose. Write an expression to represent the number of books Miguel has, and J represents the one that Jose has. Well, if J is Jose's, Miguel has 3 times that. So the expression is 3J. Multiplying the J by 3. Rosa has 5 fewer bracelets than Maria. Write an expression to represent the number of bracelets Rosa has, with M is the number that Maria has. So I'm writing the expression is she has 3 fewer than Maria, so it's 5 fewer, sorry. M minus 5. Okay, last couple. Sheldon has elementary schools, got a school store. They have parent associations in charge of buying items. They sell set of pencils that come in packs of 24. Write it down to an expression that represents the total number of pencils it has available to sell. Let P represent the number of packs of pencils. So the expression is, well, actually I can even say they have. And all I'm doing is multiplying those. 24 times the pack. Yep, you got it dismissed. Here you have to store, so that will be folded in packs of 6. The store currently has 4 packs with 4 and is ordering more. Write it down for an expression or the total number of folders it has after ordering more folders. That X represents the number of packs of folders ordered. So I'm doing the number of packs, meaning I ordered 4 more 4 packs. This would be 4 times the number of folders, but they also have hold on.
And then bring it back.
Have a pack of 6, so it's pack of 6. So it's going to be 6 times the numbers that they order, but they already have 6 packs on hand, 4 packs of 6 on hand. Yeah, that was easy to say. Meaning I need to go ahead and simplify this. So 6x plus 24 is the total number of folders. So I had a student talking back on it. Do me off. So your total number of folders is going to be that 6x plus 24. The store sells diamond-shaped rubber bracelets family pack of 24. An algebraic expression that represents the cost of each bracelet. So C is the cost of a pack of 24. So if I want the pack cost of 1, it means I need to take that pack of 24, that cost for the pack, and divide it by 24 because there's 24 bracelets in it. You can either write it as a fraction, or you can write it using the division sign, is the cost of 1 bracelet. And then our last question. Darian's band made $500 on one night. They had to subtract cost of $80, and then, that's really key, divide the remaining money among the band members. If there are 4 band members in the band, which numeric expression correctly shows the amount that each member will make? Explain your answer using order of operations. There's actually 2 parts to this. You not only have to tell me which one it is, you have to also say why. Let's focus on that order of operations, because that's how we're just explaining it. So order of operations means I would divide first, meaning I take the 80 and divide by 4, and then I would subtract that number from the 500. And expression B, I'm taking away the $80 cost first, and then dividing by 4. But when you read the problem, that's what they do. They subtract the cost of 80 and then divide it, meaning that expression B is correct. So expression B is correct because it takes the cost of $80 out before dividing the rest by 4. So guys, good luck. We've got all weekend to study. We're hoping that makes a difference. And So some of the philosophy is kind of disturbing. It's like, why do you miss a lot of what we're talking here? So if you have questions, please come in for seminar. Good luck, guys.